Hey, it's Mr. Barr, and in this video I'm going to do some IXL homework for graphing a two-variable linear inequality. So we're going to graph this, and then we have to shade it also. So let me scroll down a little bit. Okay. Oh, let's take that point away. So what am I doing here? So x equals 1 is right there. And I know that, you see that guy right there? Right here, this would just be a dashed line, but the fact that it's this tells me it's a solid line. I'm going to draw a solid line that comes right through here. But then I have to figure out where is the solution. Is it this side or is it this side? Well, I'm going to pick a test point. I'm going to test 0, 0. So let's test 0, 0. Is 0 less than or equal to 1? I plugged in the 0 right here for the x. Is that true? This is true, which means this is my shaded side. So that's what I'm going to go for here. So I'm going to put a point here, put a point there. It's a solid line. Now I come over here and do my shading. Super duper. This is fun. Okay, let's do another one. So what do I have here? X equals, or x, basically, I pretend like it's, I'm going to start with pretending, am I drawing? Yes. Pretend like it's x equals -2. So x equals -2 is right here. This is a dashed line. See that guy right there? That's telling me it's a dashed line, so it's going to be a dashed line right here. Now I have to test it. So I'm going to test 0, 0 and see if it works. Is 0 greater than -2? Yes, it is. So I'm going to shade this side of it. Okay, let's get this in. Boom. Up. Dashed line. Oh, sorry. Make a. Okay, oh, okay, there we go. Dashed line. Shade on that side. Terrific. Right, so I'm looking at okay, now I'm doing a slope-intercept equation. So this is y, this is y, this is y equals mx plus b. Okay, so my b is 0, so I'm starting at 0, and I'm going down 2 over 1, down 2 over 1, down 2 over 1. There's my line. It's solid. Now 0, 0 isn't a good test point because it's on the line. So instead I'm going to test 1, 1. Ready to test this? So I'm testing 1, 1. My x is 1, my y is 1. 1 is greater than or equal to -2. Is that true? It's true, which means my test point is true, which means everything on this side is true. Solid, solid. There we go. Okay, so once again, this is a slope-intercept, so it's going to start right here at 0. I'm going to go down 5, 1, 2, 3, 4, 5, and over 1. And I know this is a dashed line. Once again, 0, 0 is not a good test point, so I'm going to test 1, 1. Let's test it. Give me a second. I got to pause this. I'll come right back. All right, and I'm back. You probably didn't notice I was gone. So where am I? I'm testing this thing. Okay, so that's my y and -5x, -5x, and I'm going to test the point 1, 1. There has to be a 1 right there. So 1 is less than -5. That's false. Okay, this side is false then. If this is the false side, that means this is the true side. All right. Boom. That's not a good line. Brilliant. Okay, you know, this one, it's going to start at, I'm going to graph it first. So we know it's going to start at -4, and then it's going to go down 3, 1, 2, 3, and over 1, and I know it's solid. Okay, now I have to figure out where to shade it. So I'm going to test, I can test 0, 0. 0, 0 is an easy one. So is 0 is less than or equal to 0 minus 4. What I did is I plugged a 0 in right here, and I plugged a 0 in right there. So is 0 less than or equal to -4? Is 0 less than -4? No, this is false. So if this is false, that means the other side is the true side. Let's graph this. It's going to start at -6. I'm going to go down 1 over 1, and this is dashed. Now I need to test it. So I'm going to test 0, 0. That's a good test point. Testing 0, 0. 0 is greater than 0 minus 6. 0 is greater than -6. That's true. If this is true, that means everything over here is true. Starting this line at 5, going up 2 over 2, and it is solid, so I've got that. Need to figure out where to shade. So let's test 0, 0. So is 0 greater than or equal to 2 times 0 plus 5? Is 0 greater than or equal to 5? Is this true or false? This is false. 0 is not greater than 5, which means this is the true region. Graphing it, I'm starting at -4. I'm going up 5, 1, 2, 3, 4, 5 over 1. It is a dashed line. And now I have to figure out where to shade this thing. 0, 0 is a good test point, so let's test it. 0 is less than 0 minus 4. 0 is less than -4. Is that true or false? 0 is less than -4. That is false. This point right here is false, which means everything on the other side is true. I'm going to start here at -5. I'm going to go up 2 over 2. It is solid. I've got that correct. I'm going to pick a test point. I'm going to test 0, 0 because it's an easy point to test. 0 is less than or equal to 0 minus 5. 0 is less than or equal to -5. 0 is less than 5. That's false. This point is false, which means everything on the other side is true. Starting at 5. Starting at 5, going down 3 over 1. Solid line. Solid line, that looks good. Let's pick a test point, testing 0, 0. 0 is greater than or equal to 5. 0 is greater than 5 is false. This point is false, which means everything over here is true. Right, so, oh, interesting. So this is a different type of problem, isn't it? Arg. This is a different type of problem. How are you going to graph this? We can do a couple things to it. We can force it, we can rewrite the equation as this. Y is greater than -5x plus 7. That's one way to do it. I took this -5x. Basically, I subtracted 5x from both sides. So let's graph that. So I'm going to start at 7. I'm going to go down 5. 1, 2, 3, 4, 5, and over 1. There's my line. It's dashed. And now let's test 0, 0. I like testing these. This is 0 plus 0 is greater than 7. Excuse me. 0 is greater than 7. That's false. So if this point is false, That means everything over here is true. Okay, same type of problem. So let's convert it. So this is going to be y is less than negative 2x minus 5. What did I do? I subtracted 2x from both sides. Minus 2x minus 2x. Good. So I'm starting at negative 5. I'm going down to, I need to scroll. I'm going down 2 over 1 dashed line, and now I need to test 0, 0. So 0 plus 0 is less than negative 5. 0 is less than negative 5. That's false. That means this point is false, which means everything over here is true. Right, so I'm going to take that 2x and move it. So that's going to give me y is less than or equal to negative 2x minus 1. So negative 1 down 2 over 1, solid line. Let's test 0, 0. 0 plus 0 is less than or equal to negative 1. 0 is less than or equal to negative 1. That is false. So this point right there is false, which means everything over here is true. Actually, I can do this one using mini equations. I probably could have done other ones. This is, let's see, y equals negative 1 and x equals negative 1. So y equals negative 1, x equals negative 1. So there's the line, solid. And let's test 0, 0. 0 plus 0 is greater than negative 1. That's true. 0 is greater than negative 1. So this is my true side right here. You know, this one I can do mini equations. It's tough to do mini equations though, because I have to get to x equals 14 with mini equations. So I'm gonna have to move it. Ooh, interesting. 81. So that's off the graph, isn't it? Let's go fishing. Let's go fishing. Here we go. You guys remember how to go fishing? You can graph anything. If I plug in a 0, if I plug in 0 for x, 0 for x, y is 7. 10 for x, y is 2. Let's plot those points. 0 for x, y is 7. 10 for x, y is 2. Yeah, that's cool. And now let's test 0, 0. 0 plus 0 is greater than 14. 0, 0 is false, so I'm going to shade above it. Oh, and what line type? Line type. Did not anticipate that problem. Same thing here. Same thing. So even if I move that into slope-intercept form, my intercept is going to be off the graph. Is it? X is 20 and y is 5. So I know that if x is 0, y is 4, correct? And let's say x is 10, y would be 2. There we go. I've got 2 good points. Let's graph them. 0, 4, 10, 2. Oh, this is a move the x divide by the y. Am I even going to teach that this year? Let's test 0, 0. 0, 0. 0 is greater than or less than 20. That's true. That's the true side. All right, that's going to be it for me in a second. Haha. What did I mess up on? The correct answer is that. What did I do? I lost it on my line type. Okay. That's it. Thanks for watching. Bye.